Chapter 8. Let's do programming. Tech Surf. In this chapter we will learn programming, algorithm, flowchart, program, types of computer languages. Programming. There are numerous instances where something could have been written the same way in multiple languages. The need for multiple languages is probably overestimated. Humans can understand a variety of spoken languages, whereas computers understand only machine language. Let us clear it with an example. If someone asks us to subtract two numbers, we will quickly do that. But if computer is asked to answer, it will not be able to answer this, as our verbal instruction is not understood by the computer. It can only understand the instructions given in computer language. The set of instructions written in a language which a computer can understand is called a program. We follow step-by-step procedure while solving any problem so that we can get the desired outcome. In the same way, a computer also carries out its functions in a step-by-step procedure to give us accurate results. Basically, a computer program involves 3 steps: algorithm, flowchart, program. In this chapter, we'll learn about the step-by-step process involved in writing a program, from algorithms to flowcharts to final code.
Algorithm. Algorithms are all around us. A step-by-step instruction for solving a problem or accomplishing a task is called an algorithm. Common examples include
the recipe for baking a cake, the method we use to solve a long division problem, the process of doing laundry, and a mathematical or a logical problem are all examples of an algorithm. Algorithm design is setting out the steps and rules needed to follow in order to achieve the same desired outcome every time. Look at the following example to make it clear. What steps would you follow to bake a cake? The possible steps are as follows. Step 1. Preheat the oven. Step 2. Gather the ingredients. Step 3. Measure out the ingredients. Step 4. Mix together the ingredients to make the batter. Step 5. Grease a pan. Step 6. Pour the batter into the pan. Step 7. Put the pan in the oven. Step 8. Set a timer. Step 9. When the timer goes off, take the pan out of the oven. Finally, enjoy the desired result, cake. In computer programming terms, an algorithm is a set of well-defined instructions to solve a particular problem. It takes a set of input and produces a desired output. For example, an algorithm to add two numbers. First, take two numbers inputs. Second, add numbers using plus operator. Third, display the result. Flowchart. A flowchart is a type of diagram that represents a workflow or process. A flowchart can also be defined as a diagrammatic representation of an algorithm, a step-by-step approach to solve a task. Flowcharts use special shapes to represent different types of actions or steps in a process. Lines and arrows show the sequence of the steps and the relationships among them. These are known as flowchart symbols. Tech Insights. Hermann Goldstein and John von Neumann developed the flowchart in 1946 to plan computer programs. Have a look at some flowchart symbols. Start-stop box. It is an oval-shaped symbol used to represent the beginning and at the end of the flowchart. Input-output box. It is a parallelogram-shaped box that is used to indicate the input and output of a program. Processing box. It is a rectangle-shaped box that is used to show the processing part of the flowchart. Decision box. It is a rhombus-shaped box that is used to check the conditions, display comparisons, and take the decisions to solve the problems. Flow lines. These are the arrow lines used to connect the different shapes and represent the flow of the sequence. Connectors, it is circle-shaped symbol that is used to join the parts of a flowchart. Tech insights, the direction of flow in a flowchart is always from top to bottom or left to right. Flowchart helps in solving a problem or carry out procedure in a more systematic way and reduces the chance of errors. But sometimes it becomes complex if the program logic is long. Rules while making a flowchart. Follow certain rules while making a flowchart. Rule 1. Each flowchart must have one and only one start box.
Rule 2. Avoid the intersection of flow lines.
The flowchart should be clear, neat and easy to follow. Rule 3. The flow of control must not split. Rule 4. The flow of control must always enter a box from the top. The flow of control must always leave a box from the bottom, except for decision box, which allow the flow of control to leave from the side. Rule 5. If the flowchart becomes complex, it is better to use connector symbols to reduce the number of flow lines. Let's convert an algorithm into a flowchart for adding to numbers. Algorithm, Step 1. Start. Step 2. Take two numbers. Step 3. Add the numbers. Step 4. Display the result. Step 5. Stop. Flowchart. Start. Input m, n. Sum is equal to m plus n. Print sum. Stop. Start. Begin the flowchart. Input, instruct two numbers to computer. Processing, give instruction to calculate using plus operator. Output, the result is displayed. Stop, end the flowchart. Program, we learned to represent an algorithm as a flowchart. This flowchart is then expressed in a programming language to prepare a computer program. Preparing a computer program helps in solving a problem which is written in the computer language to get the desired result. Computer language. The computer language is used to communicate with computers. A computer understands the instructions given to it in its language, that is, machine language. This language uses binary digits, 0 and 1. Programmers do not write their programs directly in these digits. Other computer languages have been developed in which writing programs have become easier. A computer language, also known as programming language, is a special language understood by the computers. It consists of a set of words, symbols and codes that is used to write a computer program. The process of writing a program is called programming. To make computer understand these languages directly, some special software programs have also been developed which translate the programs written in other languages into machine language. Types of computer languages. Broadly, the computer language can be classified into two categories. Look at the chart given below. Computer language, low-level language, machine language first-generation language, 1GL, assembly language second-generation language, 2GL, high-level language, procedural language third-generation language, 3GL, non-procedural language fourth-generation language, 4GL, natural language fifth-generation language, 5GL, Action Hub. Design a pictorial representation of types of computer languages in Paint. Low-level language. Low-level languages are also called machine-level languages. Machines can easily understand it. They are written to run on a particular computer and hence, they cannot be easily used on other computers. Two main categories of low-level languages are machine language. A machine language, also called first-generation language, is a language directly understood by a computer without any translation. It refers to zeros and ones that a computer can understand as instructions. Due to this reason, it is also called low-level language, LLL. Machine language programs run only on the computer for which they've been developed and are not portable to other computers. Assembly language, also called second-generation language, is also a low-level programming language. And assembly language uses letters and symbols instead of using numbers, ones and zeros. A program written in assembly language uses short sequence of letters called mnemonic codes like A for add, B for branch, C for compare and L for load. Assembly language program is a source program which must be translated into machine language before a computer can understand it using a program called assembler. Mnemonics. Assembly language. Input. Assembler. Output. 01101001. Machine language. High-level language.
A high-level language, HLL, is very easy to understand and is user-friendly. It has instructions which are similar to English language. Programs are easier to write in this language as it is machine-independent. A program written in HLL can easily run on different platforms.
Interpreter and compiler are the two programs used to translate high-level language into machine language to make it easier for computer to understand. 3 multiplied by 3 is equal to 9. High-level language. Input. Interpreter compiler. Output. 00001001. Machine language. 3 main categories of high-level languages are procedural language. A procedural language is also called third-generation language, 3GL. In this language, the programmer writes instructions that tell the computer what to accomplish and how to do it. This language uses English-like words like add for addition or print to print. C, C++, BASIC, COBOL, Java, Visual Basic and Fortran are the examples of 3GL. Non-procedural language. A non-procedural language is also called fourth-generation language, 4GL. In this language, the programmer only specifies what the program should accomplish without explaining how. It uses English-like statements. Perl, PHP, Python, Ruby, SQL, MATLAB and Oracle are the examples of 4GL. Natural language. A natural language, also called fifth-generation language, 5GL, is a type of query language that allows the user to enter requests that resemble human speech. It represents next step in the development of programming languages. Natural languages and artificial intelligence use 5GL. Mercury, OPS5 and Prolog are the examples of 5GL. Tech Insights. A language processor is a software that converts source program into machine language. Compiler and interpreter are the examples of language processors. Data Vault. We follow step-by-step procedure while solving any problem so that we can get the desired outcome. A computer program involves 3 steps: algorithm, flowchart, program. Computer language are classified into 2 major categories: low-level language and high-level language. Machine language and assembly language are the 2 categories of low-level language. Procedural language, non-procedural language and natural language are the 3 categories of high-level language. Tech Bytes. Program. A program is a set of instructions given to a computer to get a particular task done. Algorithm. A step-by-step instruction for solving a problem or accomplishing a task. Flowchart, a diagrammatic representation of an algorithm, a step-by-step approach to solve a task. Compiler. Compiler scans the entire program and translates the whole of it into machine language at once. Interpreter. Interpreter translates just one statement of the program at a time into machine language.